Welcome, welcome, welcome. Step right up, one and all. See the amazing Visca the teacher perform calculus, magic, sleight of hand before the eyes. Actually, it's not magic. They're just numbers. I'm just playing with y'all. Welcome as we start a new journey today. Today's journey will start one step at a time through the practice 2012 AP Calculus AB exam that College Board has put out several years ago, obviously, actually 10 years ago. It has been out for a decade now. All right, we are going to start section 1, part A, which is the multiple choice, and that calculator is a big no-no. We do not get the calculator for the first 28 questions. This video will cover questions 1 through 10 of section 1, part A. Two things, as always. Like the video, you know you're going to like it anyways. That helps me. And throw a comment down below if there's a question you have about one of these problems, or if there's another test you want to see. All right? So like the video, that helps me. And follow me, because that helps you. You will get notifications when I put up the next few videos for this examination. So, I hope you're packed. Weather's going to be cold. It's November 1st. All right? Let's get started. Number 1, if y equals x sine x, then dy dx is equal to, great first problem, just testing your derivative knowledge. Product rule, it is the first times the derivative of the second, which is cosine of x, plus the second times the derivative of the first. The derivative of x is just 1. So when everything's all said and done, x cos of x plus sine of x. And if we did that correct, it looks like it is choice B, all right? Remember, in addition, order doesn't matter. I can list this first, or this first, and this second. I can. And in addition, I can flip terms. Okay? I can flip them. Very easy. Great way to start. Build some confidence. Number 2 reads, let f be the function given by f of x equals 300x minus x cubed. On which of the following intervals is the function f increasing? All right, increasing. That means my first derivative is positive. Okay, so let's first find the first derivative. First derivative of this would be 300 minus 3x squared. All right, well, if I want to see where that's equal to 0, I need to find my critical points first. Okay, because that is going to tell me where my function changes from increasing to decreasing. That's really going to set my boundaries. So I'm going to factor out a 3, and that's 100 minus x squared. My goodness, factoring never, ever goes away. That is a DOPS, or a difference of perfect squares. Okay, I'm going to solve this. The x, okay, I don't have to solve the 3. I could divide both sides by 3, and that goes bye-bye. The x on the left side has to equal 10. And the x on the right side has to equal negative 10. Okay, in order for those to be 0. Okay? In case you forgot basic math, I got to take 10 minus x and set it equal to 0. This is my answer. I got to take 10 plus x, set it equal to 0. That's my answer. So what I now have is two values that are critical points where my first derivative is 0. Number line time. Here's negative 10. Here's 10. It's my x value. It's when the first derivative is equal to 0. All right? I'm going to take values in between. I don't know, 0. How about 20 and negative 20? All right? And I'm going to see where my first derivative is positive. Okay, so I'm going to put that into the first derivative, which would be right here. I could put it in this equation. I could put it in this equation. I mean, shoot, I could put it right here if I wanted to. First of all, if I put a 0 in for this x, let's use this right here. If I put a 0 in for that, I would get 100. Okay, 100 minus 0 is 100. That's positive. So I've got a positive value between here. Okay, if I put any number, all right, if I put any number into this x, if I put a 20 in there, I now have 100 minus 400 on the inside. Same thing if I put negative 20. Negative 20 squared is 400, so I still have 100 minus 400. Okay, if I put any of those numbers in there, it's going to be negative, which means it's a downward slope. It's increasing from negative 10 to positive 10. 2 should be choice B. Three is another basic question. I need to integrate secant x tan x dx. All right, this is just testing you on your rules for derivatives. Okay, what am I taking the derivative of that would give me secant x tan x? Because remember, integrating something, this is the derivative. Integrating something gives you the original. All right? So, of course, if you know your rules for trigonometry, the derivative of secant x would give you this. All right? But since there are no bounds, I always need to put a plus c when I solve for this right here. Okay? When I solve for this right here, I need to put a plus c. And that, my friends, the answer for 3 is A. 4. Man, we are going through these pretty quickly. Let's not jinx ourselves here, guys. Let's do good. Let's do good. Number 4 reads, if f of x equals 7x minus 3 plus ln of x, then f prime of 1 is. All right, let's first find f prime. Okay, and that, wow, that's the thick one. All right. The derivative of 7x is 7. The derivative of 3 is 0. Plus, the derivative of ln of x is 1 over x. I want this at a value where x is 1. That's what this is telling me. Well, 7 plus 1 over 1, that's 7 plus 1. Goodness. I wish I was taking this test in 2012. Fancy. All right, number 5. We're going to really have to now try each one of these possible options. One of 5 options they give us, A through E. And we're going to have to see which is which. So there's going to be a little bit of analyzing here. But, you know, if you love me, if you've seen other videos, I love graphs. I love graphs and tables. They're awesome to work with. They really give a lot to the problem. Well, let's do problem 5, all right? The graph of the function f is shown, well, in this case, to the lower left, not above. Which of the following statements is false? Oh man, for every student I had that stopped reading after the word is and just circled the first correct one. Okay, there are going to be 4 of these that are true, and there are going to be 1 that is false. Okay, which statement is false? Okay, A says the limit as I approach 2 exists. Well, here's the line to 2. As I approach it from both sides, it approaches the same value of positive 2. Yeah, that actually equals 2. That does exist. I don't care if there's a hole there or not. It just has to point to the y value of 2, and it does from both sides. The limit of 3 exists. All right, well, here's 3. As I approach 3 from the left, and I approach 3 from the right, that exists as well. That's 5. That's a y value of 5. So that does. So A is true and B is true. Okay? Who cares if it's a cusp? Look what they did. They put a hole for the limit at 2, but that's fine. You can still have the limit at a hole. Puts a cusp or corner at 5 thinking, oh, the derivative. But guess what? That cusp still points to a y value of 5 for both sides. Let's take a look at 4. Okay? Choice C. Limit as f of x approaches 4 exists. Okay, here's 4. As I approach from the left side, I get a y value of 2. As I approach from the right side, I get a y value of 4. Oh boy, here we go. This points to a y value of 4, and this points to a y value of 2. Okay? They do not point to the same thing, so that means this is false. This is the one that's false. Okay? The limit, I mean, I really don't have to do anything else in this graph, but, you know, for poops and ha-has, the limit as I approach 5, same thing. It's this point. It's a y value of 6. Okay, this does not exist. And the function is continuous at 3. Yeah, a corner or cusp is continuous. Okay? You just can't take the derivative there. I can draw my pencil without picking it up, or a pen or a marker, whatever the case is, without picking that up. There's no break in the graph at 3 at all. So there you go. The choice for 5 is C. There is no limit as x approaches 4. It's undefined. Question 6. A particle moves along the x-axis. The velocity of the particle at time t is 6t minus t squared. Okay, so they're giving us velocity here. That was weird the way they did it. Velocity with time is 6t minus t squared. What is the total distance traveled by the particle from time 0 to time 3? Okay, velocity, which might be meters per second. I don't know what it is. Then there's acceleration. That's a derivative away. Position, or distance, you take the derivative of to get velocity. You need to integrate to go backward. We are going backward. We have velocity, and we want distance or position. Okay? Area under the curve is total distance. All right? So I'm going to integrate my velocity, which is 6t minus t squared. Don't forget your dummy variable, from 0 to 3. That's it. Okay? When I integrate 6t, I get 6t squared over 2. 6 goes into 2 3 times, so I get 3t squared. Minus t cubed over 3. Okay, and I want that from 0 to 3. Man, have I told you yet how I love plugging zeros in? It's just fantastic. So let's throw in our upper bound. Remember, we got 3t squared, so it's 3 times 3 squared minus 3 cubed over 3. That's putting in the upper bound minus putting in the lower bound. If I put in zeros everywhere, that's going to give me zeros, which I love. This is just one big 0. 9 times 3 is 27. 27 divided by 3 is 9. Well, that's 18 minus 0, which is 18. There you go. Choice D. Choice D. This is what you had to know, which I think is pretty common for calculus. Number 7. If y equals x cubed minus cosine of x all to the power of 5, then y prime is, oh lordy, the power rule and the chain rule. Power rule first. My exponent needs to come down. And then I subtract 1 from that exponent. The inside stays the same. Okay? Now I multiply that times the derivative of the inside. Okay, the derivative of x cubed is 3x squared minus the derivative of cosine of x is negative sine of x. When I subtract a negative, it turns to a positive. Okay? So I should have something that looks a little bit like that. And if I did that right, which I did, choice E. There you go. Nice. Okay, yeah, got to know the chain rule. Oh boy. Graphs and tables, oh my. Number 8. A tank contains 50 oils of liters. No, that would be 50 liters of oil. at time equals 4. This looks like it's going to be important. 4 hours. Oil is being pumped into the tank at a rate, RT. That's a rate, where RT is measured in liters per hour and T is measured in hours. Okay. Selected values of R of T, our rate, are given in the table above. Using a Wright-Riemann sum, that's RAM. Wright rectangular approximation method. Okay. With 3 subintervals from the data, with 3 subintervals and data from the table, man, I got to really practice more reading. What is the approximation of the number of liters of oil that are in the tank at time 15? So after 15 hours, okay? Well, 3 subintervals. Let's go. If we have 3 subintervals, here's the first one. Subinterval 1. That has a width of 3, okay? Subinterval 2. Subinterval 2. That has a width of 5. Okay, and why am I doing the width? Because remember, we always got to multiply by the width. They are not all the same, okay? 2 of them looks like they might be the same, but we can still do them individually, okay? This is subinterval 3. This has a width of 3. Okay, so here we go. I'm going to do the Wright-Riemann sum, or an RAM for this one. The right side of this blue rectangle is 6.2. I got to multiply it times the width of 3 plus, okay, the right value of my red rectangle, or subinterval 2, is 5.9. I got to multiply that times the width, which is 5, plus, okay, the right value of subinterval 3, which is the green rectangle. It's 5.6, and I got to multiply that times the width of 3. All right? Oh, and don't forget, we started with 50 liters already in there at time 4. You start at time 4. So before we add all this up, we already had 50 liters in here. So I've got to add that to whatever was pumped in from time 4 to time 15, which is this. So I'm going to add 50. Ooh, well. Yeah, there was no saving that. I put the plus 2 close to the arrow. I got to add 50 to this whole sum, okay? Scroll down. All right, 3 times 6.2 is 18.6 plus, without a calculator, 45. Carry the 4. 25 and 4 is 29. Plus 18, carry the 1, 15, 16. Plus my 50. Okay, so, oh my God, we have 1.1, 1.9. I got to carry that 1. Let's put it over the 29. So that's 30. Plus 18, that's 48. Plus 10, it's 58. Plus 6, 64. Plus 50. That's 114.9. liters total. 114.9 liters total. Oh my goodness. You don't get a calculator to do these problems. So take your time when you do them. All right? 114.9. The approximation of the number of liters of oil that are in the tank at T equals 15 hours. You know, I like number 9. It's simple, but you really just should think about it clearly, and then it becomes simple. Let f be the function defined above. For what value of k is f continuous at x equals 2? All right, so you need to find a value here for k. Let's not forget, this is the y value when this is the x value. Okay, so when x is 2, what's my k here? Okay, when x is not 2, anything else, I'm using this to find the y value. Okay, so first, let's look at the top. Okay, notice that 2x plus 1 over x minus 2 all over x minus 2. All right, first of all, If I try to take the limit, like what is this approaching as x approaches 2, I can't just plug in a 2 because of the bottom. Okay? But what happens here is these cancel. And what you should know is when something that would have made the bottom 0, okay, before I cancel that, okay, you would say there's a vertical asymptote at x equals 2, because that would have made the bottom undefined. However, when we cancel something out that would have been a vertical asymptote, that puts a hole there. There's a hole at x equals 2. So I have this graph right now. I don't know what it looks like. We got this thing here, da 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 da. There's a hole right here, right now. So they're asking you, well, what would I have to put for the y value here? What is this y value that would put a coordinate right here? Okay, because right now there's nothing there. So this green dot, what's going to be the y coordinate? All I got to do is plug my 2 in for my cancel thing. Right now, when these cancel, I have the limit as x approaches 2 of 2x plus 1. How come? Because I canceled these two, numerator and denominator. 2 times 2 plus 1 is 5. You should have a y value of 5. K should be 5 right here. Any other place where x is 2 that is not 5 will not make this continuous. This point has to be at 2, 5. Number 10. This is a good problem to end here, okay? What is the area of the region in the first quadrant bounded by the graph of y equals x divided by, or excuse me, y equals e raised to the x divided by 2, and the line x equals 2. All right, area in the region, that is integral, the area under the curve. Let's just do a little sketch here, which, I mean, you know, it's not necessary. But the graph of this would constantly be increasing. So it would look like this, something like this, okay? When x is 0, okay, when I put a 0 in for this x, that would give me e to the 0, which would mean my y value would be 1. So y would equal e to the 0, which is 1. So right here is 1. I mean, not that we needed to know that. Okay. And x equals 2. Okay, right here, x equals 2. All right? So did I need to know this? No, because they're telling me the area in the first quadrant. All right? The first quadrant is here at 0 to 2. That's why they give us the x equals 2. Those are our two bounds. If I want that area under the curve, I am definitely going to have to integrate from 0 to 2 my e raised to the x over 2. Please do not forget your dummy variable. Get into that habit. All right, so here we go. I'm going to do a basic u sub. I'm going to make u equal x over 2, which is the same thing as saying 1/2 x. Okay, the derivative of that is just 1/2 dx. I don't have a 1/2. I only have the dx to sub into. So I've got to solve this for dx. I'm going to multiply both sides by 2. Notice the right side, the 1/2 and the 2 cancel. So my dx is this right here. Ready, ready, ready? I'm going to integrate. Okay, my 2 is a constant. Just going to put that on the outside. Du is now my new dummy variable. E to the u, because in for x over 2, I'm putting in a u. Do not forget, these bounds are currently x equals. You need to change them to u's. If my upper bound is x equals 2, well, 1/2 times 2 is 1. That is my new upper bound. All right? If my lower bound is x equals 0, so now we're going to plug a 0 in here. 1/2 times 0 is still 0. That's still my lower bound, okay? Basic rules. The derivative of e to the u is e to the u. The integration of e to the u is e to the u. I do not need to write a plus c because I have bounds. I want this from 1 to 0, and oh, by the way, you still got to multiply this times 2. So I've got 2, put in my upper bound, e to the 1, minus, put in my lower bound, e to the 0. All right, well, I mean, it's pretty basic at this point. All right, 2 times e to the 1 is just e, minus e, anything to the power of 0 is 1. It's not 0, okay? And this can be rewritten, if I wanted to distribute this, as 2e minus 2. All right, so I have one of possible 2 answers that could be written up here. And if I scroll down far enough, you can see it's choice A. This bottom one here is choice A. We're done. Man, 26 minutes to do 10 problems. Including the, me talking in the intro was at least a minute and a half. Me talking to the end here, which you're probably going to stop the video now. Screw you. Like the video before you stop it. Follow me before you stop it. That helps me. That helps you. We're helping each other. The world's a better place. And I will see you for questions 11 through 20 very, very soon. Have a good night.